We're back again with Earl Meredith, NOAA's coordinator for the Sentinel Site program here in the Chesapeake Bay. And we've talked about sea level rise. We'd like to talk, Earl, if you would, about how that sea level rise is affecting the marshes and the uplands here in the 3,100 miles of coastal shoreline.
Mm-hmm. Well, we have about 5 sites that we monitor for biological communities in salt marshes and in sand dune areas like Assateague Island. And so people are measuring the biomass of seagrass, for example, above.
Excuse me, could you tell us what biomass is?
Biomass is just the physical weight of seagrass or a biological organism in a particular measured unit. So it would be pounds of grass, for example, in a square meter of salt marsh. And so they're measuring the volume of grass and the weight of that grass, both above ground and below ground, to monitor the health of the salt marsh. And they're also measuring the community of organisms there, the biodiversity, how many different species are there, and what their abundance are, and whether they're thriving or not. And so the monitoring of these salt marsh areas help us project what the future may have in store for these communities as the salt ocean inundates these areas in a more frequent and more more times of the year.
Something that you talked about with salt that I found fascinating, and we're going to jump from Chesapeake Bay up to Greenland, but that in the melting of the ice masses up there, the fresh water is coming down into the salt water, and then that you would think that would be a beneficial thing, and just in terms of the organisms that are living in the water. But in effect, what you've said is that the fresh water is actually hurting the organisms that are living in the salt water.
Mm-hmm. Yeah, there's some evidence that as the Greenland ice shield is melting, it's freshening the surrounding marine environments. The large marine ecosystems are becoming fresher, less saline. And that has an effect on the microorganisms that live in those areas, and then all the way up the food chain to cod, for example. So there's some research going on to see how the fresh water and the freshening of the ocean due to glacial ice melt is affecting fish populations.
And then back again to the Chesapeake Bay, the amount of salt in the water and the amount of water that's coming in that is salty is affecting our shoreline in what way?
Well, a number of different ways. One way that's fairly obvious is if you are traveling around the shoreline, you may see areas where the salt marsh and the upland forest interface. And what you may see in certain areas like Blackwater National Preserve area, where the salt has intruded up into those upland forest and actually killed a lot of trees right along the margin of the salt marsh. And so you actually see dead trees lining the salt marshes there because of the salt intrusion. And also another aspect that we're looking at is the salt intrusion into the freshwater aquifers. And so as the salt water rises and moves up into these areas, what effect is that having on our drinking water, for example? So we're looking at a number of different aspects of how sea level rise and salt intrusion in these habitats and in communities, human-built communities, in terms of flooding, communities that are being inundated and the streets are blocked off. So restricting emergency vehicle movement and actually affecting property value.
Well, that's another interesting thing about the surface water. Um, the aquifers being affected by the intrusion of the salt water, but also there's also the depletion of the water the water table lowering, and then the salt still affects that as well.
Well, yeah, agricultural practices and municipal use of water is indeed extracting, water from the water tables, and so that's having an effect in terms of the availability of fresh water, but it may allow the salt water to intrude more readily into areas along the coastal perimeters.
But then the flip side of that is that the agricultural communities raise soybean and corn, and they take up the nitrogen that you don't want to have, and the carbon that is so prevalent in the atmosphere.
Right. Well, that's another aspect that people are looking at and researching in terms of the carbon that's in the atmosphere that gets sequestered by the ocean or by the water in the Chesapeake Bay. And in terms of that sequestration of carbon and then the chemical reactions and the release of more hydrogen ions actually has an effect of creating a more acid water base. And so ocean acidification is something that people are looking at. And we're also looking at the anoxic conditions on the bottom. In other words, you've heard of dead zones. Well, these are areas where the dissolved oxygen in the water has been depleted, and the chemical interaction there may be creating more acid in the water column. So could be a combination of anoxic conditions due to potential runoff from the terrestrial environment into the bay. It creates these dead zones, and then the effect that has on the benthic community or the organisms that live on the bottom of the bay and the bottom of the ocean, things like blue crab and oysters. And so the effects that deoxygenated water has on the biological organisms, as well as the chemical reactions in the water column and the creation of potentially higher acid conditions. So there's a lot of research going on for that right now.
And NOAA, out of their Chesapeake office in Annapolis, also is studying the oyster reefs, and so your study does have some integration with their studying as well.
Yeah, the Oyster Reef Restoration Program that's run out of the Chesapeake Bay office, they're searching for habitat areas that are most appropriate for reestablishing oyster reefs. And so part of that is the water depth that the oyster reefs can readily survive on. And then the bottom type as well. They like to have a harder bottom, more rockier substrate to live on. So as sea level rises, one thing that we need to be cognizant of is where the oyster populations can thrive in a given water depth. And so as we are looking at sea level rise and trying to model that, it's important to take into consideration what aspect sea level rise will have on those communities in the bottom of the bay.
I'd like to talk about tides and magnetic pulls. I find that fascinating.
Mm-hmm. Yeah, tides are very important, and when we have these coastal storms, particularly like Sandy and Isabel just recently, the combination of the tides, a high tide, and then the storm surge, the wind blowing across the top of the water and forcing water up against the shoreline, and when the tides are high, can create some very severe flooding events like we saw in New York City. Similar things have happened down in the Norfolk, Virginia, the Hampton Roads area. So it's a combination of tides, the magnetic pull of the Earth and the Moon, and then the wave action and the wind action of storms, all in conjunction to sea level rise, are potentially creating conditions where we need to really be cognizant of these aspects. And when we're designing and building infrastructure in communities, we need to be informed of these different factors so that we can make the best decisions on where to build things.
And we were talking about the Gulf Stream and how it's actually lessened in our area, and yet because it's lessened, it's actually been detrimental to us.
Mm-hmm. Yeah, the Gulf Stream brings warm water up from the Caribbean and the tropical zones, and it flows kind of in a northeastern pattern excuse me, along the Atlantic coast. And that warmer water and the expansion of the ocean are correlated because it's the old physics equation, pressure, volume, and temperature. So as the temperature rises, things are going to expand. And so the ocean temperatures are rising a couple of degrees, and the Gulf Stream is bringing this warmer water, and that has an effect on expanding the volume of water in our area, which is contributing to sea level rise.
Well, before we end, I think it's really important that we talk about, I only have about a minute, but talk about greenhouse emissions and how we can actually help the slowing down of sea level rise.
Well, that's a very tough question, and I think we can, as individuals, we can try to contribute by trying to burn less carbon. There's a lot of research that shows that the more carbon, the greenhouse gases that are produced, it's sequestered by the ocean, and it's causing some sea level rise and some ocean acidification. So if we could all just be cognizant of, the amount of driving that we do and trying to come up with alternative sources of energy, that would be the recommendation that I think we should all think about.
Well, Earl, it's been a pleasure having you here today, and I think that we've learned an incredible amount about the water around us, and I appreciate your work and what you do.